So what I want to cover today is the SolidWorks evaluation tools, and they consist of many tools, some of which are in the standard package, some of which are part of professional and premium. Since most of the folks on the line don't have professional premium, I'm going to focus today on just what is in the standard package of the evaluation tools. Now, the evaluation tools are really what SolidWorks has chosen to put on a tab on your command manager called Evaluate. So we're going to go through each of those and talk about some of the features that maybe you aren't aware of. I mean, probably everyone's using interference detection, everyone's using measure and mass properties, but we'll talk about some of the details of those and maybe some tools that you aren't necessarily familiar with. So here are the ones we're going to cover today, not necessarily in this order. Some of them do play off of each other. Some of them you'll find on the Evaluate tab when you're in parts, some you'll find when you're in assemblies, but we're going to try to hit on these within our hour together today. So I want to start out with the easy one. Most people are using this. It's your interference detection. Most of us, I think, do understand what we're capable of doing with interference detection. You can see some of the things there, typically used in the assembly environment. But I want to show you kind of some of the things that they've added lately in this environment, just to give you a sense of, how a perspective of looking at those results and how you can understand what you're really getting here. Because I think sometimes we run this, and if we do have interferences, sometimes we kind of gloss over it a little bit because of some of the things that it does present. So let's start there. Evaluate tab on the command manager. If you do not have it, just right click on one of the tabs and turn on Evaluate. Okay, everyone should see a visual now. If you do not have it, just right click on one of the tabs. You'll be able to turn on Evaluate at this point. That will give you access to all the tools. Now this will look a little bit differently depending on whether you're in parts or assemblies. And like I said, I'm going to focus on the stuff in standard. Some of this stuff is added in the professional and premium edition, so I want to make sure I stay away from that. But interference detection. So we have a small assembly, and when I calculate the interferences, we're used to being able to select those interferences. There's a couple things that are kind of maybe you haven't worked through yet. We obviously have the volume of interference. We can expand and see the two components that are interfering, and it does allow me to pick and see those two items. One of the things you may not be aware of is this option at the bottom that tells us what to do with non-interfering components. So non-interfering components, when you have a larger assembly, it's hard to see some of these interferences. So what I like to do is tell the software what to do with components that are not part of my selection up here. I can actually tell them to make it hidden. And now I can physically see when I select on the interference, it will isolate just the two components that are interfering, and now the red area is the volume of interference. I can very easily take a look at that. Now there's also in here the ability to set them to wireframe and set them to transparent, so you don't necessarily have to hide everything that is there. I tend to use hidden quite a bit. One other couple things that is in here that may be important. This was added in 2013. Because one of the issues with the interference detection tool, if you're not careful, is that it's going to bring up all your interferences of your fasteners and the threads, because we model the threads such that there is an interference with the fastener because we're not physically modeling them. Now, a couple things we can do here. First thing I'm going to show is this option that we had before that's called Create Fasteners Folder. When I say create a fasteners folder, what it does is all the interferences that belong between fasteners and its adjacent parts are now stored in a folder, and the trigger typically would be, hey, you know what? It's a fastener interference. I'm going to ignore it. which then you get to the assembly stage of this thing, and that particular fastener doesn't fit in there, or there's an issue with the relationship between the hole and the actual fastener. So one option that I want to bring up is this one called Create Matching Cosmetic Threads folder. If I turn on this option, what it physically does is it now takes the fasteners and it organizes them even further. We now have any fasteners and holes that have cosmetic threads that physically match. In other words, the hole definition matches the definition of the threads on the fastener. Okay, so they have the same diameter, so these will fit together. But in situations where you have a mismatch in the cosmetic threads, now these are things or an alert where we can go back through and make some change. Now you'll notice that some of these are just listed as coincident interference. One of the options that we do have, again in the interference detection, that you want to be aware if it's on or if it's off, because this will give you some tricky results, is this treat coincidence as interference. If that is on, any face that is touching will report as an interference. Well, this is great if you want to make sure you have contact between components. But if you have that on by default, which it's not in SolidWorks, but you could be coming up with interferences that you might not necessarily want to have. So let me just recalculate that without the interferences that we were just discussing. So you can see there's still several mismatches as it relates to the cosmetic threads. A couple other ones that really don't require too much description here. Treat subassemblies as components is going to ignore if there's any interferences within a subassembly. Let's say you downloaded something from 3D Content Central or GrabCAD and it was full of interferences, but hey, you wanted it to visually be in there. You didn't want to mess around with the interferences. And it happened to be a subassembly. You can tell it to treat that subassembly as a single component, so the interferences between the individual components won't be reported. Another one is, again, related to downloads or maybe weldments and so on. But if you have a multi-body part and it has interferences between the bodies, we can also include those interferences with this option here. If bodies are hidden or components are hidden, do you want them to be ignored in this process as well? So my message here is really understanding what options you have on are very important within this tool. And most importantly, if you have fasteners in your assemblies, being able to take those interferences and sort them a little bit. Now, what about interferences like this, where you have an O-ring and an O-ring groove, where you've actually modeled in some sort of press fit or interference that you have to have? I want to remind everyone that you do have the ability to ignore those interferences, and they are remembered. So if I right-click and ignore those two interferences, they now disappear from my list, and now I only have my fasteners and cosmetic threads, and I can focus on cleaning that up, but I don't have any other interferences within the assembly. It does list and show you the number of interferences that you do have, and you can actually turn on as an option to show those ignored interferences. You notice the color is taken out of the icon to let you know that those interferences are currently being ignored. Now let me just do this. Now here's another kind of gotcha. Notice I have no other interferences other than what's ignored. My fastener folder's in here and I got cosmetic threads. This option, Create Fasteners Folder, can actually cause you to miss something. If I turn that off for a moment, let's just look through the interferences that are listed here. That's definitely a fastener interference, right? But look at this one. It's thinking that this is a fastener interference because it's between a fastener and a component. It's not really looking at the cosmetic threads. So there is kind of a repercussion for using this fasteners folder. I would tend to, as you go forward, use this create matching cosmetic thread folder. Because it isn't going to show you these types of interferences if you use the other, or it's going to try to categorize it as a fastener interference. So lots of different things in here, lots of different options, but you kind of want to make yourself aware of all the different tools that are available in there. All right. Next one, very much like your interference detection, it was added a few years back, called clearance verification. Really neat tool. You'll have to have a certain scenario where this will need to be used, but definitely can provide some pretty neat results. So here, the scenario I have here, let's say we have an electronic box of some sort, and we need to be able to make sure that we have clearance between components that are emitting heat within the assembly. So clearance verification right next to interference detection. Now what we can do is we can check clearance between a component and all other components in the assembly, or between a face and all other components in the assembly. In this case, we know that we're going to be emitting some heat from the heat sinks, and we want to make sure that we have at least a 10 millimeter clearance between the heat sink and any other component within the assembly. Now, what am I going to check clearance between? I can select other items in the assembly I'm worried about, or I can tell it to check the entire assembly. Now, before I do that, notice the bottom of this. A lot of the very similar options that we just saw in interference detection, like ignoring clearances that you want to have next to a certain component, or treating subassemblies, or creating fasteners, or uninvolved components. But let's go ahead and calculate this. In this particular case, it finds two components that are a certain distance away from this particular component, and I can expand it and see that, okay, it's a heat sink and there's the component, and the same thing here, including the version number that from the tree of that component as well. So now I can go ahead and make a change and move those if I wanted to, and I could rerun this verification and see if I've got any more clearances. Now, one of the other things I want to mention is we can check clearances with faces as well. So if I wanted to check the clearance from this particular face on a component because of the heat, check again for the 10 millimeter clearance, you can see I do have interference, or I'm sorry, a clearance issue between one of the other components on the board. I can choose to make the move and recheck. But there's also a clearance between that and the bottom of the board here, and this would be a perfect example of where you might ignore a clearance as well. And I still have the option to show the ignored clearances. Now, obviously we can go in and measure and do some of that, but as your assemblies get busier and busier, this helps you to do a kind of a global look in as to how close things are from a particular component, if there is any kind of thermal issues. But clearance verification, part of your evaluation tools. Continuing on, a tool called hole alignment. Now, hole alignment, one of the things we need to talk about is exactly what it will work on. It's going to use features to figure out whether holes in your assembly are aligned. Now, it only evaluates hole wizard holes, simple holes, and cylindrical cut features. It does not work on imported or derived parts. So I have a very simple example here. Let's get rid of this for a moment. Let's see. So you may have seen this one in the past. We've used this as an example. Let's just mate this thing up. And this is a real life scenario, where you're you're mating things up, and everything seems to fit just fine. Everything mates just fine. So you know at least the two holes that you've mated are working well or lined up well. But what about the third hole? That looks great. You know, visually, that's pretty good. Well, here's where the hole alignment tool can come in. I can tell it I want to check alignment. I want to check alignment between this component, and this component, or I can do it through the entire part. I can tell it what the hole center deviation, what the maximum hole center deviation can be, and I'll just put in a number here. And I can tell it to go ahead and calculate that. So what it's done is it's looking at the different hole types, the cut extrude, the hole wizard holes, or the simple holes, and it's given me a deviation from center to center or axis to axis on those holes. And what you can't visually see here, but there's a very, very small 0.05 millimeter deviation in this hole, the center hole here. So there actually could be an issue trying to get the fastener in there. You're going to strip the threads. I mean, there could be something like that. But this tool is going to allow you to search the assembly to find holes that are misaligned. Now, one thing I will kind of caution you, if I pick the entire assembly, it's it's going to do a lot of analysis to try to figure out what is and should be aligned here. So you may get some things in here. You can see that these holes are completely across from each other, but they deviate by 0.48 millimeters. Well, they're not intended to have something that runs completely across the part, so not really a big deal in this case. So this does here's an issue right here in the entire assembly. There's a deviation between the holes on one side and the hole the other by 1/10 of a millimeter. That will allow you to at least make the adjustments on the holes if need be, if you put in a wrong dimension. So a hole alignment, another one of the tools. Continuing on, most of you are aware of this tool, obviously, in its usage. I just want to point out a few things with the measure tool. The great thing about measure, it's available in all the environments and pretty much between anything and everything that we're able to measure. And now with 2013, we can go even further with that. So I'm just going to show this real quick. If I look at my gearbox here, let's launch our measure command. Now they've kind of been adding things to the top of this lately. Again, just options like you would see in interference detection. The first one, let's get it out of the way. The ability to change your units at any point. If I want to measure in English or metric units or any of the units that we're dealing with, the number of decimal places. The one thing I do want to point out in here as it relates to accuracy level, if you're really looking for accuracy of measurements, just drag this thing to higher. It says it's slower, but I have not seen a situation where I would say it's slow. So I'm not really sure exactly what to be expected there. Now, I did do some analysis of lower versus higher as far as measurements, and you have to go out 7-8 decimal places in order to get any kind of change due to this accuracy level. So I would just kind of leave it where it's at. Typically going to be good enough moving forward. So let's start. Let's say we pick this cylindrical edge and maybe this cylindrical piece here. Obviously we get our delta XYZ. We have an option in here to turn on and off the XYZ measurements, but this gives me in each direction the deltas. One of the ones that's useful here when you're picking two arcs is the pull down menu that allow us to pick whether we're going center to center, so the center of this arc to the center of this arc with the distance. In this case, when you have gearing like this where you want to figure out the center to center distance between the shafts, It's a great way to do that. Or minimum distance between them, the maximum distance, or there's a custom distance in here. Let me go in here. Custom distance, you can go min to center, min to max, and notice the little call out in here that allows us to also make our selections from here. Now, one of the new ones is the ability to do what we call point-to-point. So let's say you've moved something into position here and you kind of want to get an idea of how far away the gear teeth or what kind of clearance you might have. Well, if I try to measure traditionally, you know, I can grab the face. Let's see if I can get the edge. Okay, I can kind of get something there. Okay. But what if I wanted to know an exact point distance? Here's where I can say point to point, and wherever I make a selection on the initial face, it's going to show me an exact distance to the point I select in the next face. And if I start moving my cursor around and making new selections on the second face, you can see that it updates the distances. So I can get a real live idea of how far away these two parts are. Another thing that's important here that they've added is the ability to see measurement history. This is part of 2013. As you've in a session measured a bunch of things, you can actually go back through and see what those values happen to be. A lot of times you're having to remember it. Now it's all here within the window. There's one other option in here. We're going to have to wait a little bit to actually show you this. There's an option in here to create a sensor, which happens to be another one of our evaluation tools. So we're going to kind of go through that in a little bit. Want to also remind everyone that measure is obviously always on in SolidWorks, but you have limited capability. So if I were to select a point and a second point, you can see that my distance deviations, delta XYZ, are there on my items at the bottom of the SolidWorks interface. Okay, so measure, everyone's kind of been through that for the most part. Couple things with mass properties, again, not a whole lot here. Some new things with the center of mass here. The ability to override mass values, include hidden parts, and mass properties in assemblies. So let's use this for an example. So if we invoke our mass properties, it's going to go through each part and it's going to analyze what the individual mass for each part is, and it's going to summarize it in a total mass for the assembly. Now here's where that becomes a little bit tricky, is a lot of times we're modeling things simplified. We're downloading them so they don't have all the features, or they don't have all the parts, or we're downloading a subassembly and putting it in our assembly. So there's issues with using that as an accurate measurement of mass. So there's a couple things that we're able to do. One of them pertains to, let's say we had this gear here, and we knew the mass of this because when we purchased it, they told us what the mass was. Well, if I go to mass properties, instead of allowing SolidWorks to calculate the mass based upon the material or the default density, what I can do is override the mass properties. In other words, if you've went to a website on a purchased part and you know how much this thing weighs, you can actually input the value. That way, when you get to the assembly, for things that aren't modeled, for things that are downloaded, you can still get an accurate mass. Okay, you can override the mass value, the center of mass, the moments of inertia in here as well. The other feature I want to point out in there that's kind of new for 2013 is this Create Center of Mass feature. If I select that option, what's going to actually happen here is it will create a center of mass feature for the part. Okay, let me make sure that's off. All right. And what you'll see is this little orb at the location of the center of mass for the part. Now if I go back to the assembly for a moment here, it does understand that that is a feature that it can show within the assembly, and you'll notice as I mouse over it, there's a little part symbol next to it to let you know that's the center of mass of that particular part, and I mouse over it, you can actually see the icon. But also in the assembly, this is how you create the center of mass for the assembly file as well. So if I want to say create center of mass feature for the assembly, it will go ahead and do so and place that in the assembly file. Notice the symbol is a little bit different when it's in the active document versus in the part file. But all these center of mass symbols show up at the top of the feature tree. Okay, so that's kind of where the mass properties goes. A couple neat things in here when you get a lot of stuff going on as far as calculations in the assembly, you may want to use the copy to clipboard or the print options. I kind of wish they had some of this for other tools inside of SolidWorks, but only seen it in the mass properties. Okay. Section properties, there's really not much to bring up here before we get into some good ones. Rules on section properties is it must be parallel planes, but something you may not know is it can be sketches if you wanted to calculate the section of a sketch as well. So section properties, you can select multiple faces. The rule is the faces must be parallel or on the same plane. So I can select 2 faces, 3 faces, have it calculate. It looks a lot like mass properties. We have the same set of options like measure and mass properties as far as accuracy and the settings and units. They're all the same in these. We do have print and copy to clipboard in here as well. If I were to have sketched something, you know, some profile, I can also use the section properties to calculate the area of these as well. So it's not just of this cross section. So if you have a sketch that you're trying to figure out how much area you're covering, you can do that. Okay. And for those of you who just haven't seen this in a while, want to remember how we do just a section of the housing. It's an extrude feature in the assembly, and so it's an assembly feature cut, and that assembly feature cut, there's an option in there called feature scope where the cut only cuts through the components that you selected. So it's a cut through only certain components in the assembly to give you kind of a cutaway. Okay, in case you're wondering. Okay, continuing on. Now some ones that you just may not be aware of. They're there, you know, you've seen them there, just not sure how or when we can use them. Now there are some more advanced functionalities to these next couple tools if you have the simulation package, but I want to show you what you're capable of doing in the standard package. So this tool called sensors. Sensors in a nutshell will monitor properties and let you know when you're beyond your limits. We can do it for mass properties, dimensions, interference detection, and we can use it kind of as a proximity switch. You know, when am I within the proximity of a certain part? Okay, and we can modify the notifications of that. So let's take a look at that. I have an example here. So we have an assembly. We'll start it out here. And it's a working assembly. It does have some movement to it. Okay, if I get this thing to move. Okay, it doesn't want to move all of a sudden. Let's see here. Huh. Weird. This ain't going to work if I can't get it to move. Okay, I'm going to start with another example and we'll come back to this. So sensors is located in the feature tree. you have the ability to add sensors to your parts. Let me just remove this one for a second. To add a sensor, you just right-click, select Add Sensor, and as I said, there's some ties in with simulation. But let's say in this particular case, I really wanted to monitor the mass of this part as I'm adjusting dimensions and trying to optimize things. So I can tell it I want to look at the mass properties of this component. It tells me that the current value is 0.59 kilograms. Well, let's say I wanted to find out when the value, we got to be below a certain weight. So we're going to go ahead below 0.48 kilograms. So the sensor, okay, let's just go back in there just for one moment. I want to, okay, we want to know if it's less than, my fault, less than 0.48 on the value, and you can see that there's nothing, no messages up here. You can see the current mass value. So now I can come in here and start to make some changes. I can say, okay, what if I made it this thickness? And now when I make the thickness change, you can see currently that there's not an issue up here. If the sensor needs to be updated manually, you should have a little message on here that will tell you that it's out of date, essentially. And you can go through here and update the sensor. Now let's just change this one for a moment, and I'm not going to rebuild the part in any way. You'll notice, well, I should be getting a flag here. Well, this one doesn't want a flag. Lots of things not working. But you'll get a flag on the sensor telling you it's out of date. This one happens to be updating along with it. And if you ever meet that requirement, let me just make this something very small here. Okay, there's the warning. Not up to date. I can go ahead and update the sensor, and now I've reached the 0.48 value. One last time, I should be able to reach my threshold here. Okay, as soon as there's the flag I was talking about. It flags you when you've reached a certain warning, your value that you wanted to monitor. Now, when it notifies you is really up to you. If you right-click on the sensors folder and select notifications, you can warn me about sensors that trigger alerts every rebuild, every other rebuild, every fifth rebuild, or same thing with out of date. So you can have it flag you very often or not so often, depending on what's here. So that's kind of a nice one with sensors, with parts. Now if I figure out why this thing isn't moving here, we can do it with the assemblies. Let's just set them up and I can kind of show you what we would do here. So with sensors in an assembly, one of the ones I like to use is measurement. I can say, you know what, I'm worried about the measurement between the end of this face and this fastener here, and it actually can store that measurement. Now, what part of the measurement am I worried about? Is it the angle, the normal distance, regular distance, the delta value? Well, I'm worried about the normal distance between these two. And I want you to alert me if it's greater than or less than a certain value. Maybe, these things can't be more than a 1/4 inch apart. So the great thing is, and what I wanted to show you here is, as I move the assembly through the motions, I can get alerted when my parts are too close, when there's an issue like that. Now there's also something called a proximity sensor. If you're doing automated equipment and you're trying to use motion, part of SolidWorks, to calculate some things out, one of the nice pieces is to create it kind of a prox sensor. We can actually come in here, place a prox sensor on a component. Okay, tell it to alert me when components get within 10 millimeters of this part, and you can tell it which components you're concerned with. So I'm worried about when this particular rod is within 10 millimeters of this component, I want to be alerted of it. So I can create this proximity sensor that will actually notify me that it's done so. So pretty neat tools with sensors to kind of do some things when you're working right along. The next one is really neat. Design studies have been part of simulation for quite a while, but they've given the ability to use this tool as part of base SolidWorks to evaluate and optimize things like mass properties and dimensions inside of SolidWorks. So let's show an example here, and I've kind of made one up, created a simplified version to work through with you. So something very simple, and the geometry is kind of goofy here, but what I did is I created some form of a container, and then I created a body that represents the volume inside of that container. So I've created a body, and what I really need to do is be able to modify dimensions in SolidWorks and determine if I've got the optimal volume within the container. So in order to do that, yes, I can start changing SolidWorks dimensions and then using my mass properties and looking at the mass properties of a single body and find out what the volume is, and this happens to be 44.27 cubic inches. Well, I want to get as close to 30 cubic inches of volume as I can. So here's where a design study would come in. If I launch my design study on the evaluation tab, this is where I'm going to set up what dimensions I'm going to modify here. There's a section called variables. If I select variables, we can add parameters. Now notice it automatically turns on your dimensions within SolidWorks. I can select a dimension, give it a name. I'll call this my rib length, and then I can go ahead and work down. Maybe I want to adjust my height of the bottle possibly. Make sure I got the right one selected here. And let's cancel this for a second. I want to turn off my, okay, it doesn't want to cancel. I think I'm stuck. Okay. I want to just turn off the Instant 3D, which is launching here. So making sure that we can make a selection of a dimension. This is the height of the bottle. And then maybe we want to know the depth. We're going to work on that as well. So 3 dimensions that you would be modifying manually typically, we can now work with here. So once we apply them, we can now choose which of those variables we're actually going to put as part of the design study here. Now, in order to do that, you can see rib length has already shown up, and my rib length is really the distance from top to bottom of my container in this case. So let's say I wanted a rib length from 1. It can be up to 2 inches, which it is now, and it can be modified or have variations and steps of 1/8 of an inch. If I want to add the other variables to the study, I can add my depth. In this case, my depth, I don't want to be less than 1.25, and the max in this case is going to be 1.75. And again, I can set a variation. We'll just do 1/4 inch in this case. And the last one is going to be my height. This bottle can't be any less than 4.5. And the max height is 5 with a 1/10 of an inch variation. Now the next thing I want to do is give it something to optimize to. Now you can see there's 162 scenarios here. So what I'm going to do is going to add a sensor that we just introduced. I want to find out the volume property from the mass properties of this particular body. Now for some reason it comes up in millimeters even though it is in inches, the units, but I can tell it to alert me when it's less than, let's say, 32. Okay, let's say that's my volume option. Now from here, what I got to do is just make sure that constraint is added, and then I can go ahead and run these scenarios. There's 162 variations with the steps that I provided. But this is the great thing. Try doing this manually and getting a result that you're satisfactory to. So it's going to run through all the scenarios, all the variations of how we can modify those dimensions and track something. In this case, it happens to be the volume of the part to try to give me what I think is the most optimal configuration of the part to meet my volume needs. So this is one example of how you might use this. There was 163, but it's going to lay out all the scenarios here and what the resulting volume of that inside part happens to be. And now I can go through and say, you know what? Well, let's see here. This one was at number 9 is at 34. Well, I like 34, but really my rib depth needs to be a little different. What if I change my rib depth up a little bit? Oh, okay, that takes me up to the next scenario. Okay, that's 38, and I can kind of work up and down. Yeah, well, what happens if I start to decrease my rib length? What happens there? So it's called a design study. It's part of Evaluate. There's some neat things. If you have simulation, I recommend you look into it. It's awesome with simulation. Some really neat things there. Okay, next tool, assembly visualization. We're kind of getting close on time here. This is by far my favorite tool that's on the evaluation tab. I've shown this in past lunch and learns. I can't emphasize enough how awesome this is if you can get this implemented in your day-to-day world. So let's take a look here. Let's use this one here. So assembly visualization is used to evaluate your assembly for all sorts of things. I'm sitting here, I have my assembly together, I want to now break things down a little bit. I launched my assembly visualization. What it does is it gives me a listing of all the components in the assembly. Now how I view those is up to me. Do I want them grouped for components that are like components as a single group with a single value? Or do I want them grouped together so all M1.6 cap screws are together? Now what we're looking at is the mass in order, so the lowest mass to the highest mass of the components that are in there. And you'll notice that there's this color bar also within the assembly. Now if I click on that color bar, it's going to now shade your assembly so that the items with the highest mass are the purplish and the ones with the lowest mass are in red. Now I can also add this little value bar to show you how much different they are. You can see, these are very, very small in comparison to the larger ones. I can also use a command called group identical. So items that are identical in mass will then have the same color. The software is going to go ahead and provide you with the colors on that and sort those. So let's reset that for a moment. Now, right now I'm sorting on mass, but another thing that I'm able to do is add more columns to this to start to analyze my assembly. I can edit the column. If you right-click on the column there, you can actually use this little arrow over to get access to other things. Like, am I looking at the state, the total cost, the author, or all the other SolidWorks properties that we deal with. Now in this case, let's say I wanted to look at volume. Okay, so now it's sorted by mass, but it's now listing the volume of each part. I can also add this to my sort hierarchy. So what this does is, as it's finding items of similar mass, it also places them in the proper order as it relates to the volume of components as well. So it's a two-edged hierarchy. The one that I kind of like to use here is things like material. I use this a lot. So now I have this looking and showing me the different materials I have within the part. And I'm able to go to individual parts, and I can now use the little arrow to actually assign materials. So think about getting to the assembly level and you've forgotten some of your materials. You can go ahead and, oh yeah, this is this particular material. It will apply it to all the components without an issue. If I add another column in here, another thing I want to show, let's say you're required to put descriptions on all your parts. Well, I can go ahead and show the description listed here. But here I obviously have missed one. Okay, I can actually type in descriptions using this tool as well, and it will push that information to the individual part files. All the while you can use this as a method of sorting alphanumerically, sorting by mass, using colors to do that as well. And then on top of that, let's say I wanted to find everything under a mass of 5. I can use these little slider bars to now isolate and find everything of a certain mass or of a certain material. For instance, we can sort by material. Let's move this to the front of the line here. Okay, now we can sort by material, and I can use my little slider bar. Here's everything made out of 6061. So I think this is probably one of the best tools as part of that, but one of your SolidWorks evaluation tools called Assembly Visualization. Awesome tool. Okay, continuing on, almost done here. Two that I want to bring up, the Assembly Expert and one called Feature Statistics. They kind of go together. One's for parts, one's for assemblies. Assembly Expert, what most people aren't aware of is the amount of things that the Assembly Expert can report on. I kind of recommend using this as a tool that you run each time you have an assembly, maybe before a final save. It can report on some of the things I'm going to show today, components that are too far from the origin, if you got verification on rebuild on, if you have display speed errors or a number of mate problem. All of that can be reported with this particular tool. So we'll again use this assembly. Assembly Expert is right next to Assembly Visualization. It's going to automatically report for us a bunch of things, and what you're looking for at the bottom is kind of a guide. Warnings are the X's, check marks for passed, and the other one's just kind of a diagnostic list. Sometimes, here's a file that hasn't been rebuilt, so it tells me, hey, some reports are not available. This is an important one. So I'll just exit out, use my Control Q for a forced rebuild, if you're not aware of that, and just go back in for a moment. You'll notice that there is actually more reports available to me. So it tells me the number of mates that are being evaluated at the upper level assembly, the total number of components, whether large assembly mode is on or off. An important one that will slow down your assemblies, how many of the documents are updated to the latest version of SolidWorks. Well, these little glasses in here also can provide you with more information. This actually gives us a full list of any documents in this assembly that aren't converted to a 2013 file. We can save the list, print it, make copies of it. We can also select individual components and isolate them from here. Just really neat tools all kind of built in here. If I return the Assembly Expert, at the bottom it does give us kind of a good look at the overall assembly, how many components, how many are unique, the depth, how many sub-assembly levels you might have, and so on. A couple of important ones for speed, number of top-level mates, number of bodies. If you're not aware of what verification on rebuild is, Okay, this option here, verification and rebuild following tools options, system options performance is turned on. This is kind of just telling you, hey, you don't really need that on. You can turn that off. Only turn it on when you need it. This will slow down your assemblies. Now, one other thing I want to show that it does do. Let's just make a copy of a fastener here. And we'll drag a copy out of there. And let's do something real crazy. We're going to go ahead and move the component by a delta value. And let me do something first. I want to just swap my units here. So we're going to move a component by delta XYZ. Come on. Alright, and let's just pick a crazy number here. So I'm going to make a component disappear off the screen a little bit. We're going to go ahead and apply that. Now, some of you have maybe seen this when you're dragging components around. You hit your F key and zoom to fit and the parts disappear. If you go to the evaluate using Assembly Expert, one of the things that it also does is a component check. Your component is very far away from the origin. They're very small on the screen. It actually has some of these an Analyze and Fix button. If I select Analyze and Fix, it will actually bring the component that's out in space closer so you can visually see it on the screen and move it back. So if you've ever hit the zoom to fit and your assembly kind of disappears or it zooms way out, that's why. Okay, so I suggest you look at Assembly Expert and all that it has to offer, and maybe just start using a Control Q rebuild before you save your assembly the last time. Make sure everything looks okay with that. The other one is feature statistics. Not a whole lot here, but if I were to open up an individual component and use the evaluate, there's the statistics option in the part file. And what this does is it organizes the features in the order that it takes for them to rebuild. This helps you to make determinations of maybe creating a simplified configuration, or something's wrong with this feature. It's taken 3 minutes to rebuild versus tenths of a second on other features. You can also, if you right-click on any of them, perform operations on the features here as well. One thing I caution you here is you do have to do a rebuild to get accurate numbers on this, or latest numbers. It's based upon the last rebuild. So now if I go in here, I can find out this is the feature taking the most amount of time to calculate within the software, and these are the ones that take almost nothing. So you can kind of concentrate if you get a slow part on particular items. If I go back to the assembly, I do want to point out assembly visualization also has the option in properties is the SolidWorks rebuild time. So in the assembly level, using visualization, I can see which components take the most amount of time to rebuild from the assembly level using visualization, something I kind of skipped right over. And again, you can sort and do those types of things with that as well. Two that are kind of focused on the part side, curvature and zebra stripes. Curvature is a little bit harder to understand, but it's really there to help you analyze the curvature of a part that you're creating with lots of curved geometry and shapes, plastic parts and so on. Zebra stripes is kind of like a reflection of light onto the part. So let's just take a quick look at that. Let's see here. There it is. So let's take a look at zebra stripes for a moment. Now, hopefully this is coming across the webinar okay. It's kind of a little goofy. But it's supposed to show you the reflection of light across the surface so you can work on the curvature between those items on that surface. And you can see that the light definitely meets up, so it's tangent, but the light beam does get deflected, saying, the curvature is different at those locations. Well, one of the things we can do here is, as we create better fillets, better blends, you'll notice that these things are going to change a little bit. I'm going to go ahead and do a different blend in here using the fillets. I'm going to use a face fillet between this face and this face. And instead of applying a value for the radius, I'm going to tell it I need it to be tangent here and tangent here. We also have what we call curvature continuous, where it actually matches the curvature of the outside of the bottle and the bottom. So it changes curvature very slowly. And notice the difference in the reflections here. That's just to show you that, look, the curvature matches in these locations. It just gives you a better blend, a better look and feel. Well, the same thing goes for the other tool, which is curvature. Now, curvature is the inverse of the radius of curvature. Okay? So let me just go back to my PowerPoint here for a second. Curvature equals the reciprocal of the radius. So whatever the radius is at the location, you take 1 over radius, and that's actually the curvature. In layman's terms, what you're looking for here is large, quick variations in curvature. You want the curvature and the colors to slowly and gradually change to get a proper blend. If I was looking at the middle of this bottle and saw a black surface, which is a flat surface, I would know that there's something wrong. There's a wrinkle in my surface, a blemish that I'll probably have on my plastic part. But I can use curvature to figure that out. And the last one today is one we call Symmetry Check. This one's very simple. Just evaluates how much symmetry you have on individual components using the faces or body itself. I just got a real simple example here. If I use Symmetry Check off Evaluate, I can tell what planes I want to do the symmetry on. We'll just pick one of the planes. And it's going to find unique faces, symmetric faces, asymmetric faces, and I can go ahead and have it check the part for symmetry. Okay, this will work on imported parts as well. So if you're worried about something being off here, you can figure that all out. So anything that's symmetric, I can select those faces. Any of the green faces are symmetric about that plane. Any faces that are unique on one side versus the other, and then any asymmetric faces, which is the face that crosses both boundaries as part of that. Now, one of the things this tool can also do is automatically do a symmetry split for you. Now, it can take a body and cut it in half or in quarters, and you can tell the software, you know what, split the part there, and it will actually create half the part for you using symmetry. Again, I think this tool is just really used for verification a lot of times of whether I did create a symmetrical part or not, and can give you some results just to kind of verify your own thinking. So that's what I had today. All of those tools are part of SolidWorks Standard. If you could pick one or two to kind of move forward with that I think are pretty neat, I think design studies can be useful, and I definitely think the assembly visualization. Let's see if we have any more questions here, and then doesn't look like we have any more questions. There will be a Lunch and Learn next Wednesday if you haven't signed up on sheet metal, how to go from 2D to 3D with sheet metal.